in touch. Today we have Chris Hardin, who's going to talk about Angular 6 dependency injection. There are some interesting new features in Angular 6 for dependency injection, which has otherwise been pretty unchanged since the beginning, and we're going to learn, I guess, how valuable they are in real projects. So take it away, Chris.
Okay. As you said, I'm Chris Hardin. I work for Oasis Digital. I've been an Angular developer for several years now, and before that, I taught dependency injection using Java Spring. So I'm used to talking about dependency injection. Before we get into the Angular 6 features, I kind of want to start it from the beginning and just the basics of what is dependency injection and how does it work in Angular before we get into how it's changed in Angular 6. So real quick, what is dependency injection? It's often referred to as inversion of control as well. Basically, the idea is without an injection framework, every object is responsible for creating its dependencies and knowing enough about their implementation to configure them properly. And so with inversion of control, we want to take that responsibility away from our object and put it into the framework or container of some sort. So in Angular, the injector plays that role. The injector is responsible for knowing how to create a dependency and or how to locate it. In Angular, dependencies are listed in a kind of a declarative fashion using tokens. The idea is that using a token value can abstract away the actual implementation. So our objects are not tightly coupled to the actual implementations of their dependencies. And so which brings us to the benefits of dependency injection, which one is decoupling. And along with decoupling comes greater portability. So it's much easier to take a class and reuse it in another context if it does not internally create its dependencies. We can put it into new context, inject different dependencies, and it still works. Also, that makes it easier for testing, so we can easily inject mock versions of our services and dependencies. Okay, so in Angular, the injection framework is implemented as a tree. At the root of that tree, we have the root injector, which is available for your entire application. And I'll go into each of these in more detail in later slides. So we have the root injector, which is for your whole application. And then for each component, we get a new injector as well. So part of the injector tree mimics the component tree in your Angular view. And then the complicating factors when we get into lazy loaded modules. So an injector gets created for each lazy loaded module. Within a single injector, services are always singletons. Okay, so there's never more than one instance created within the same injector. And since it is a tree, if a service is provided again at a lower level in the tree, that shadows a service provided with the same token at a higher level of the tree. And then I have a little note here at the bottom. I'm going to use the word service just to mean anything that can be injected, whether you really want to call it a service or not, because we can inject primitive values and things like that too. So I'm just going to use service to refer to anything that we inject into a component or another service. Okay. And we're going to kind of demo in the Tour of Heroes app. I'm going to use that to demo kind of how this injection tree works in a few minutes. So going through each one in a little more detail. So at the root provider, or at the root level, we have providers. So root is, of course, the very top of the injection tree. Anything provided here is available for your entire application, whether it's lazy loaded or not. Once a service is requested for injection, or one service is referenced and created, then its lifecycle is now tied to the lifecycle of the application. So if it's at the root level, once the service is created, it's not going to get destroyed until your application shuts down. It's always there. Okay. And my last point here is that root is really the recommended default when you're deciding where to put your provider. And that's especially true with the new syntax. I'll get into that a little bit more later. So component providers, we can think of each component in our tree. So when we load up an Angular application, we have app component at the top of our component tree. And app component includes other components in this template, and we build up a tree in the view. So Angular creates a corresponding injector tree as well. So each component in your view is represented by its own injector in this injector tree. And as we look for, if the component asks for a service to be injected, Angular first looks at its injector for that component and walks up the tree. So looking at its parent component's injector, so on until we get to app component, and then ultimately to the root injector. So behavior really changes when you start providing services in the component. So before, when we provide services in the root, the services lifecycle is the same as the application's lifecycle. When we move providers down into the component, now the lifecycle of that service is directly tied to the lifecycle of that particular component. So if we say navigate to another view and come back, and a new instance of that component is created, it's going to get a new instance of that service. So you cannot share state in between instances of a particular component if you provide a service at the component level. And any service provided at the component level is also available to any child components. Okay, and I'll show an example of that in a second. Okay, so some use cases for why you would do this. I think the most legitimate use case is if you have some sort of editor component. So let's say you have a complex editor component that has nested components inside of it to make up a rich editor. And let's say that you want to have all of those, the parent component and its children, communicate by using a service to share that kind of transient editor state. And now let's say that you want to allow the user to edit multiple things at the same time. So you have multiple editors on your screen. So you want to make sure that each editor component has its own instance of that service that's sharing data so that they don't overwrite each other. And if you're familiar with other injection frameworks like Java Spring or something like that, I know in Java Spring I would really call this a prototype bean as opposed to a singleton. Okay, it's a singleton in the context, in a very limited context. It's a prototype in the sense that each new component instance gets a new value. Okay, and then we get to lazy loaded module providers, and for me this is where things get complicated and uncomfortable, and I really want to avoid it. With the new syntax, it's going to be much easier to avoid these complications. So every time you lazy load a module, Angular creates a new injector for that lazy loaded module. This injector is a child of the root injector, and if anything gets provided in this lazy loaded module, it's going to shadow anything that was provided at the root. And it doesn't sound too complicated, except for, okay, if your lazy loaded module imports a shared module, and you have services provided in that shared module, you end up accidentally getting multiple instances of things when you didn't necessarily intend to. Okay, so now for the demo. So I took John Papa's Tour of Heroes GitHub repo and pulled it down and made it intentionally more complicated. So basically I just took his and moved everything into modules so that we could demonstrate some of the features. Otherwise it's pretty much exactly the same as his app. And hopefully by now people have seen Tour of Heroes before. So pretty much every component is in its own module, and some of them are lazy loaded and some of them aren't. And again, this is the old syntax, and then I'm going to show how things change with the new syntax. Okay, so I'm using augury here to show kind of the injector tree and to demonstrate some properties. So first let's look at the non-lazy loaded route here. And first let's make sure I'm running the current version of the code. Okay, so I have two routes. I have the dashboard route and the heroes route. The dashboard route is eagerly loaded, so there will be no lazy loaded injector. It will be just the root injector and the component injectors. And then the heroes route is a lazy loaded module, so we'll have the root injector, the lazy loaded injector, and the component injectors. So if we look at, so again, right now we're on dashboard, and I have a service called HeroService that is provided in app component. Which actually, let me go ahead and show that. It's just an app module. Yeah, put it in shared module. Actually, no, okay. Sorry, backing up a bit. So I have a module called shared module, and the idea is that I want to put all my services that are kind of common to my whole application in this shared module. I would probably also have directives and some components in here as well. So here I'm providing HeroService. Okay, and so this shared module is imported into my app module. It's also imported into my HeroList module. Okay. And this would be an easy mistake to make. So I call this a mistake because HeroList module is a lazy loaded module. So by importing shared module here, I've just duplicated my HeroService. And I probably didn't intend to do that. Okay. And I say that because I did this for real and it took me a while to figure out. And then I never did it again. But so that's sort of a complication. And the other thing is you look at this HeroSlist module and there's nothing about it that says, hey, I'm a lazy loaded module, okay? You only know that if you look at the routing and you see how the routing definition is. So it's very easy to accidentally start importing things into lazy loaded modules. And I'm going to, here, let's switch back to the demo here. Okay, so looking at the demo, we have the dashboard route, which is not lazy loaded, and I want to look for HeroService. So I'm going to click on any of these components. And so here in Augury, I can see the component tree that's currently loaded. If I look over here at the injector graph, it shows me the tree of component injectors directly under the root injector. Let me pick one here. I think this is... Okay, so we'll look at dashboard component. Okay, so dashboard component requests the HeroService. And so over on the right, Augury is trying to show us where the HeroService came from. And so at the top here, it shows the root injector. And then underneath root, it always shows basically your component tree, which again is the same as your injector tree. And this dashed line here means that HeroService came to us from the root injector. Okay, that's pretty straightforward. If we look at properties, Augury is going to show us the properties that exist on my dashboard component. And so I can see that dashboard component has a property called HeroService. And on my HeroService, I've added an ID. So every time a new HeroService is instantiated, I increment a global counter so that I can tell if it's the same instance or not very easily. So here I see the value of 1. If I click on an app component and do the same thing, it also says 1. Great. Okay, now if I switch to my Heroes route, and do the same thing. So I'm going to click on Heroes component, which also injects the HeroService. And now I can see that it has an ID of 2. So we got a new instance because it's a lazy loaded module. And again, that's probably not what I intended to do by importing the shared module. Okay. Okay. So the other thing I want to illustrate is, let's go back to dashboard, is the component hierarchy. So if I click over here, let's see, on search box, you can see I have multiple HeroSearch components. And so in HeroSearch component, if I go to the code real quick. Okay, so in HeroSearch component, I've provided the HeroSearch service directly on the component. So it's only available to this component and its children. So if I click on HeroSearch component, and I can see that HeroSearch service here has an ID of 3. If I click on its child, it also has an ID of 3, so they're sharing the same instance. If I go to the other search component on the same screen, I can see that has an ID of 4. So I can see that they're isolated to each HeroSearch component. And then as I navigate away and come back, you can see that I got more instances created. Okay, I think that's... Okay, there's one other thing I want to point out. Oh, yes, sorry. There is one thing that is a little confusing with Augury. So the reason that I put this ID property on there is because Augury wouldn't show me what I wanted to see. So I just wanted to point out that limitation. If I click on Heroes and Heroes component, now we know that Heroes component is getting HeroService from that lazy loaded module injector. But if I look at the injector graph in Augury, it's not telling me that. So Augury is only showing me the component tree, and then at the top of the component tree is showing me root. And so here it's misleading because it looks like HeroService is coming from root, when really it isn't. Another thing I found interesting, so right now, Hero's component is getting the HeroService with an ID of 2, right? Because it's getting a new instance from the lazy loaded module. Now if I go into my code and I change app component, and I say, you know what, app component is going to provide HeroService. And I reload this. Okay. Now, Hero's component, it's in the lazy loaded module, but now HeroService has an ID of 1 because the HeroService coming down from app component took precedence. So the component injector always takes precedence. So I find it somewhat hard to reason about. So you walk up the component tree all the way to root, but root's not necessarily root, because if there's a lazy loaded injector in there somewhere, then things get complicated. Which comes back to my original statement of try to avoid providing things in lazy loaded modules because it just overcomplicates things. Okay. Let's see. Okay, so I'm going to look at the bundles now. So I have packaged this already. So if I go to my dist folder, actually, okay, sorry. I have a service hanging out here called extra service. So if I look at my shared module, I have something called extra service. Okay, it's using, the standard decorator. It is provided in shared module. Okay. Now if I search my code base for extra service, it's not actually being used anywhere. I have the file where it's declared, and then I have the shared module file where it's listed as a provider, but nobody's actually using it. And so maybe I was using it at one time and then I stopped using it and I don't even realize that nobody's using it, but it's still in there. So if I look at my dist bundles and I search those for extra service, it's still there. So I'm still taking the cost of having that in my bundle. And in fact, it's in my main bundle. So since it's in shared module and shared module is imported into app module, even though nobody's using it, that is in my main bundle and it's required to load before my application can even bootstrap. And so that's what the new syntax is going to try to avoid. Okay. And shared module. Okay. So I'm going to move along here. Okay. Oops. And okay. So on to what you came for, which was the new syntax. So in order to make it easier to do tree shaking, Angular 6 introduces a new syntax of this provided in property on the injectable decorator. And so you can do it 2 ways. You can say provided in and then pass in the string root, which says that no matter where this service physically is located in my source tree, it's always going to be associated with the root injector. And it's not going to be affected by lazy loading. You can always expect it to be in the root injector, and there's only going to be 1 instance. Okay. You can also specify an actual module. Oops. So here I have provided in hero module. So that means that this service will be included, will be created by any injector that includes hero module. And that gets a little more complicated. So again, if we change this to shared module, right? So if I said provided in shared module is imported into app module. It's also imported into my lazy loaded module. So by saying provided in shared module, I would get, again, 2 instances of this. Okay, so you have the same issues with the lazy loaded modules if you say this, which again is why it makes sense to always default to root unless you have a real use case for not doing so. And it's not just me saying that. There's at least 3 different quotes in various spots in the Angular documentation that now say, please default to root on this. Okay, it just makes life a lot easier. And if you're worried about providing it at root, and then if you're worried that, well, let's say I'm doing a library or a shared module and I don't want to force my users to use this particular implementation or something like that, it's not really going to be included unless somebody references it directly. So if nobody injects it into a component or a service, it's going to go away. It's going to get tree shaken away. It's not going to be created. There's no overhead. Also, if you want to override this, so you want to provide a different value with this token, you can override it in the provider's array of any ng module or component. Okay, so these do not take precedence over things that people put into the ng module definition. So it's easy to override, and it's not created unless it's actually used. So there's really no drawbacks. Okay, and this is, again, just talking about the benefits. Again, tree shaking, if it's not actually referenced for injection, it's going to be dropped because we've removed that hard reference from the module file to our service file. And it also improves our bundling and our code organization. So now, if I have my service and I say ProvidedInRoute, okay, that doesn't mean that my service is going to go into the main bundle. So if that service is only used by one component that sometimes gets lazy loaded in some remote feature, that service code is going to get bundled with that component. It's not going to get bundled in my main bundle. It's not going to slow down my application bootstrap. So that is also another big advantage. Also, thinking this way is going to help our code organization. So because of the lazy loaded module problem, a best practice, and in the style guide, was to have a core module where you put all of your services that you want to make sure stay singletons. So then you end up with this core module. It's kind of a grab bag of services, all of which have to be loaded before you can bootstrap your application, and stuff isn't logically organized in your source tree. But now that doesn't matter. So now we can just say ProvidedInRoute. We can put our service class where it makes sense, anywhere in our source tree, and it will get bundled next to the things that are actually using it, not next to the module files. And so we get optimized bundling. Okay, so I'm going to modify our application to use ProvidedInRoute and see how it affects things. Okay, and I'm just going to move this up for a second. Okay. Okay, so I have a bunch of services down here in shared. So I'm just going to switch to the new syntax, which is that simple, and go into HeroService and switch it. Oops. Okay, and I think that was it. Okay, so I'm going to remove the line from shared module that was providing those two services and remove the imports. So now there are no references from the module itself to my service classes. Okay. And so one thing I'm going to do is go ahead and bundle it. Let me just do this. Okay, so I'm going to do an ng build. Just really quick. Okay, and I'm going to go to my dist, and I'm going to, there. I'm going to go to my dist folder, and I'm going to do the same search I did before. So I'm searching in the folder for extra service, and you can see that it no longer exists. So it got tree shaken away, and my bundle is now smaller. I'm also going to look for HeroService. And where is HeroService located? Bum, bum, bum. Okay, this one's a little harder to show. It's probably going to be in main because main is referencing it all over the place. But okay, mainly the one to look at was extra service. Okay. Oh, the other one I want to show is Hero Search Service. Okay, sorry, got too many things going on here. Okay, forget that. So let's look at augury for a second. Okay, so I'm going to reload my application, which I didn't serve, so that's not going to work. Hold on a second. Okay. Okay. All right. So you can hear the main thing is looking at my lazy loaded module. And now you see my lazy loaded component now gets an ID of 1. I think I have another change I forgot to take out? So it happens when I don't exactly follow my own script. There we go. Okay. Take that and change we had out. So right now, HeroService is not being provided anywhere. It's not being provided in component. It's not being provided directly in a module. It only has the ProvidedInRoute. So now, when we look at this, we should see that it still has an ID of 1. So our application is a lot simpler because we don't have to worry about this lazy loaded module. Okay. So then, okay. The other thing I want to do was change it to shared module. Let's see. So going to HeroService. Okay. So the other thing I can do, though again I don't recommend it, is change this to a specific module. So I can provide that in shared module. So this is the actual type. So this is a hard reference here to shared module. Okay, so I'll do that in HeroService. I'm going to do that in extra service. Okay, and it recompiles. Okay. So now when I reload, okay. Now it says 2 again. So I'm back to having my lazy loaded injector issue. Okay. So in that way it works the same as it did before, but we still get the tree shaking and bundling benefits. Okay. All right. Going back to the slides here. Okay. So we have another demo here of a potential pitfall. Okay. And for that, I actually just went ahead and did this on another branch. So let me switch here. What? Just do it. Okay. So my ng-serve now is showing some warnings, and that's intentional. So what it's complaining about, and you probably can't read that hideous yellow, it says circular dependency detected. Okay, and I'll show you why that circular dependency exists. So let's go to, let's see, where did I put it? I think it's in HeroSearch. Okay, here we go. So we have that HeroSearch component on the screen, and so it's in its own module, HeroSearch module, which is right here. And you can see it doesn't reference any providers. But now instead of providing, was I supposed to do that? Yeah, let's just get rid of that. Okay. So instead of providing it in the component, I am instead providing it using the provided in syntax. Here we go. Okay. So my HeroSearch service, I say HeroSearch service is in the HeroSearch module, and I want it to be scoped to that module. So I'm going to say provided in HeroSearch module. Okay, great. But if we look at HeroSearch module doesn't reference my service, which is good, but it does declare HeroSearch component. And if I look at HeroSearch component injects HeroSearch service, which references HeroSearch module. So there's my circle. Okay. So the recommended way to fix that, go here, just do it, is to create another module called API module. Okay, and you see it's empty. So the point is not to actually declare anything in here. But then in my HeroSearch service, I can say provided in HeroSearch API module, which doesn't reference anything else, so we know there's not going to be any cycles. Okay, and then in my HeroSearch module, which does have my declarations of my components, I simply import HeroSearch API module. So by adding a little extra layer of indirection, I've broken that cycle from the component to the service back to the module again. Okay. There we go. Yeah, okay, not too bad. Yeah, yeah.
So the cycle you're referring to there, it's not really a cycle about the, oh, sorry.
Okay.
So the cycle that you were referring to there, that's not a cycle of like creating a cycle in your dependency injector tree. That was for your module imports, right?
It's really, yeah, it's really like at the file level, right?
Gotcha.
Yeah, because
Thanks.
you're trying to compile this file, and this file references that other file. Yeah, it's really more at that level. Okay, where are we at? Okay, so just some more details of other things you can do with the provided in syntax. So, you know, in the module decorator, when you have a list of provider, a lot of times you just list the class name, okay? But you can also use the extended syntax to say use value, use class, use factory, or use existing. That same syntax is also available in the injectable decorator as well. You can do it exactly the same way, okay? And I do have an example of that in a second. You can also use this new syntax with injection tokens. I don't have a good example for that because I couldn't really come up with a reason why I would do that. It doesn't really go along with the way I use injection tokens. But if you had an injection token and you actually wanted to specify the implementation here, you can do that. So I have a little dummy example here. You can say provided in. Again, you can say root or specific module. And then this has its own special syntax for actually providing the thing, though. So you have to use this factory property with this function, and then you can create something and return it. So it's a little more specific. Again, I really can't think of a good reason why you would want to do it that way. So I do have a little demo here, inspired by Kyle. Okay. Okay. This should be good, hopefully. Okay. Hopefully I don't have... I might have screwed myself up. Let's just get rid of any changes. Okay. So I've decided that I want the HeroService to be different based on different environments. Is this right? Oh, you know, it helps if I switch to the correct branch. Hold on. There we go. Okay. So I've decided that my HeroService needs to have some environment-specific behavior in it. Okay. So I have an abstract class now called HeroService. Okay. So it's an abstract class. All the methods are abstract, so it's really just serving as an API definition and as an injection token. Okay. And you can see I have multiple implementations. So I have dev service, prod service, and test service. And they all implement HeroService. Important point with the implements, it looks a little weird because HeroService is a class, and normally you extend classes. But in TypeScript, you can either extend or implement something. And since we're not getting any actual implementation from our abstract HeroService class, we're just using it really as an interface definition. Okay, it has to be a class so that it can be an injection token, but really it's just an interface for our API, and we want it to go away at compile time. So by saying implements HeroService, then I'm getting confused. When you implement it, then that information is only for the TypeScript compilation, and then it goes away at runtime. At runtime, we don't actually have a superclass. Okay, it's just there so that TypeScript during the compilation can do type checking on our calls. Okay, so going back, and again, so it just implements HeroService. Going back to, and you can see here that I've got an ID property on here, which we'll see in the debugger in a second. So here this one says dev, and this one says test. Okay, so we'll be able to distinguish them. Now going back to the interesting part, which is our injectable decorator. So here I said ProvidedInRoute, and now I'm using some additional properties. So I have use class and an array of dependencies that are needed to instantiate this class. Okay. Now the interesting part is that I'm actually going to get the class and the dependency array from my environment file. So if I go up here on line 7, I'm saying get this HeroService provider object from my environment. And so let's see what that looks like. So in my environment file, so this is the base one that I get by default, I've just added a property to environment called HeroService provider. It's a simple object literal, And here I'm specifying the implementation class and an array of the dependencies that particular implementation needs, because my different implementations might have different dependency lists. So I put this into my environment file, and so when I compile my application, and here let me show some of the other ones. So that's HeroDevService. I have my environment.test, which says HeroTestService. Again, it might have different dependencies. So then when Angular compiles my code, I'm going to pass in a flag to tell it which configuration I want to use, dev, test, or prod. And it's only going to keep one of these files, which means that this reference to HeroTestService, I'm only going to actually be referencing one of these implementations, which means the other implementations will be tree shaken away. So in my final bundle, if I compiled for dev, I'll have HeroDevService and no others. Compiled for test, I'll only have HeroTestService and no others. Because these files get deleted, there's only ever one environment file in your bundle, and it's the only thing that has a hard reference to your actual implementation class. So that way, if you have 3 different implementations, you don't have to load all 3 implementations if you're only using one. And so in my HeroService, I just import that from my environment, and I use those values to configure my injectable decorator. And so I'm going to demonstrate that. So what's going on in my terminal here? Okay, so I should be running, this is ngserve with no configuration flag, which means I should be using just the base environment file. So if I go here and look at my application, let's reload it. Okay, and go to dashboard, and it was HeroSearch So let's look at my search component, HeroSearch, and that's not. Oh, I'm sorry. Jeez. HeroService. There we go. Okay. HeroService. So here you can see that HeroService is really a HeroDevService, and also you can see the ID is dev1. Okay. So now if I go back to here and I kill this, and now I say ngserve -c equals test.
Is that the short for environment? Is -c?
So in Angular 6, environment changed to configuration.
Oh.
Yeah. Yeah, that screwed me up. Yeah, it did. They changed the flags. So if you were doing -env equals whatever, you can't do that anymore. It's -c. And actually, if we have a little aside here, because I got burned on that doing a deployment. Yeah, so.
Does anybody in the room know that? Can you do that? Only because it's proving off too.
Yeah.
You are.
Yeah, you upgrade to Angular 6 and you hit deploy and it doesn't work. So just real quick, looking at the angular.json file, which also changed with Angular 6. If you look at this, let's see. Okay, so in angular.json, we got projects. I only have one, so it's tour of heroes. Okay, look under this stuff, and eventually you find configurations. And so it used to be that we had all these different flags. So env really meant which environment file do I want? And then there were other flags that say, do I want source maps? Do I want optimization? Do I want AOT? All this stuff. And then we had like the -prod flag, which was really like a set of these things, right? So they took that away. There's still the -prod flag, but really what's nice is you can control everything exactly the way you want it with these configurations and just do -c. So if you look under configurations here, you see I have production, okay? And you can control each flag right here. So I can say, do I want optimization? Do I want source maps? I can turn those off and on. Do I want AOT? All of those things I can control right here, in addition to controlling my file replacements. So here I'm saying, what's that?
Which can be more than just your environment file now.
Yeah. So this is an array of items. Okay. And so you can do whatever you want to here. And you can, and so if I look down at test, anyway, and if you don't specify the flags, then it goes back to the defaults. So here I added test, and I just added the file replacements, and really it works the same as my dev defaults because I didn't specify anything here. And then for ngserve, anyway, so now I do -c equals one of these things, and it does all that stuff. To get ngserve to do it, you have to add a little more configuration. Not really sure why, but so if you look under here, we have a serve, and we have configurations here as well. And so to get this to work, it has production by default. I had to add test because I added tests to my other configurations. And so here, now I say, okay, yes, I have a test, and I want it to run Tour of Heroes build test, which is really a reference to what I added up here. And so ngserve will run with whatever settings I put here. So you have a lot of control, which is that one little -c flag, which is nice. Okay, so. Oh, and it didn't. WebStorm doesn't like to highlight the console. There we go. So I'm running ngserve with a configuration of test, so I'll be using environment.test.ts. And now if I switch to here and reload my app, now you can see that I'm using Hero Test Service. And again, if I were to actually build this thing and look at the bundles, Hero Test Service would be the only implementation I would actually find. Okay. Slides. Okay. Okay, so a couple of other random things. For root and for child. Okay. We're used to seeing this with the router module, and we still will. So there's really two things that the for root for child pattern give you. One is a way to pass in configuration data to create a module. So with router module, we call router.module.forRoot, and we pass in our routes. So that's configuration data that's needed to configure the router service. Okay, so that's not going to change. We still need that. Now, the other use case for doing this for root for child thing is, let's say I'm writing a third-party library, and I'm writing a module, and it has a bunch of directives or components or pipes in it, but it also has some services. And I want those services to be singletons, but in order to use my directives and my pipes and stuff, I've got to import that module into any other module that uses those. So then I have a problem. If my user wants to use my directives at the app module level and at a lazy loaded module, if I just do a standard module, they're going to get multiple copies of my services. So the idea of for root and for child was to say that, okay, if you call for root, I'm going to give you a copy of the module with the providers and the pipes and all that stuff. If you call for child, I'm going to give you a different version of the module that only has the declarations for pipes and directives and so on, and does not have any of the providers, so that you can avoid the lazy loading issue. But now, we don't need to do that. So you can simply change your services to say injectable provided in root, and that's no longer a problem. If you do that in your third-party library module and you hand that to somebody, they can import it wherever they want, and they don't run into the lazy loaded non-singleton issue. And I do not see any disadvantage to doing that. Because again, when you say provided in root, it only gets created if it's actually requested for injection. It gets tree shaken away if it's not. It's easily overridable by putting a provider in any provider's array. I don't see, correct me if anybody else has another idea, I don't see any disadvantage to doing that. Okay. The last thing is testing. So one nice thing is if you say provided in root, those always get added to the root injector if they're referenced. So if you're testing a component or a service that requests something for injection, and that thing is provided in root, you don't have to explicitly list it in your test module. So it's a little less work for you. Again, if you want to mock it out, you do the same thing you've always done. You list it in your test module, and it works as you would expect. And if you want more information about testing, you can see Lance's talk from last month. And references. So the modified version of the Tour of Heroes application is available on my GitHub repo, as well as a link to the slides. Then I have just a couple spots in the Angular documentation that I used to research this. And then also a very interesting article from somebody who I think is German, whose name I cannot pronounce, that was very interesting with some more advanced topics on dependency injection. And then, this last link is, again, Lance's talk from last month. So that's it. Okay, thanks. Any questions?
I got it. Anybody have questions?
I'll ask questions.
In Angular 5, they introduced the static injector so that your dependencies are actually injected at compile time. So if you're missing a provider, it'll throw at build time. Does that still happen with Angular 6? I haven't tested it. I was wondering if you know.
I don't think there's any difference in that stuff.
Okay.
Anybody else?
Oh, that's cool. Maybe that'll inspire somebody else.
So it seems like it just seems kind of complicated. Like there's just like a lot of functionality there. And like the example you gave, like swapped out for a different, I guess, configuration, I just learned, I have to say. That's pretty cool. But other than like kind of cases like that, like what percentage of the time do you need to even think about anything other than just like pasting in that injected in root thing?
Yeah, well, I would say try very hard not to need any other use case. So, I mean, yes, your life is simplest, your application is simplest, it's easiest to reason about when you just say injectable provided in root, and that's why it is the recommended default. It's what the CLI is doing now when you generate a service. It just, everything works more simply. For me, it makes everything feel more like Java Spring, which always makes me feel more comfortable. And you know, it just things behave the way you would expect them to. I would think that anything else would be a more advanced use case. And so, yeah, I just upgraded a couple applications to Angular 6, and pretty much I went through and just ripped out all my provider arrays and said provided in root everywhere, moved some code around to make it cleaner, and everything was great. So. Okay.
You've blown us away.
Okay.
So advanced.
Yeah, I'll check the live stream chat.
See if anybody's chat questions.
Okay.
Okay, well, I guess more applause.
Thank you.